A replica is a copy of the database table or data in the table. And replicated databases are databases that have multiple replicas on different storage devices. They provide a few advantages like high availability. If one storage device fails, then one of the replicas is accessed on a different device. There's fast and local reads. A fast read is when reads are concurrent on separate replicas without interfering with each other. And local reads are reads that can be local, which means no network delays in a distributed database. There's also backups where one replica can be backed up while transactions are executed in another, and security where you can restrict updates to one replica with a specific user role. Although there are some good advantages, replicated databases can be slow or have inconsistent updates because they need to be done on all the replicas. Also, replication can make server administration more complex because DBAs need to figure out how to work with all these replicas. And for these reasons, replication is typically used for parallel and distributed databases where there are frequent reads and infrequent updates, and it's okay to have some inconsistencies in that case. A storage array can update data in a database replica without interfering with the database. This is pretty simple, but not so simple in a distributed database. If you update the replicas in a distributed transaction, then it will be consistent but also slow. It could also fail if any of the replicas are not available. And luckily, there are two commonly used techniques to update replicas for distributed databases. There's primary secondary, which sets one node as primary, updates primary first, and then updates secondary nodes after that. And this method is eventually consistent. And then there's group replications, which updates nodes in a group where it broadcasts that an update's going to happen, and then it makes sure that there will be no conflicts with any of the concurrent transactions. And when one of these nodes in a group is able to commit the updates, the rest will soon follow, and it eventually becomes consistent. So there is a rollback if there's any conflict that happens. Catalog contains info about database objects, including all the tables, columns, keys, and indexes, and it helps to access data and process queries. Distributed databases need access to the catalog so they can process queries. Within the distributed database, a catalog can be a central catalog that's located entirely on a single node, and this makes it easy to manage but slow for queries from remote locations. And also there could be a bottleneck because every node is trying to access the same node that has the catalog. And replicated catalog is where each node has a copy of the catalog, making it fast and reliable. But updating the catalog can be complex since all replicas need to also be updated. And this can increase network traffic and cause failures if a replica is not available in a distributed transaction. Many distributed databases use a replicated database since updates to the catalog don't happen too often. And there are also some variations of these two structures as well.